right, so we're now in section 7.2, which discusses ellipses. It is another type of conic section. So if you look at our double-naped cone right here, that is a section of it. And if you look at that orange piece right there, you get this shape right here. Oh, I may have an orange already right there. You get that shape right there, and that's an ellipse. Okay, so let's talk about ellipses. An ellipse is the set of all points P such that the sum of the distances between P and two distinct fixed points called foci is constant. Foci is just the plural of focus. Foci is the plural of focus. It's two focuses, right? Two focus. That's what that's the plural of it. It's not foci, it's foci. Okay, each ellipse has two axes. The major axis is the longer axis. The minor axis is the shorter axis. The foci of the ellipse lie on the major axis, and they are c units away from the center, where we find c by using c squared equals a squared minus b squared. Now, that means nothing to you right now, but it will shortly once we start graphing. Okay. Other things that you need to know here. A is the distance from the center to a vertex. A is the distance from the center to a vertex. And B is the distance from the center to a co-vertex. Watch this. Move, delete, co-vertex. Now, you might be saying to yourself, what the heck is A and B? What are you talking about? We don't have the equations yet. So first before we talk equations, let's talk vocabulary. So you know what these words are, what we're looking at: co-vertex, vertex, minor axis, major axis, foci. So we're going to use this one just solely for labeling. Okay, so this is an ellipse. When we graph them, they'll look like either a horizontal ellipse or a vertical ellipse. So I'm going to use this one here to name all the important parts. So right in the middle right here, this is the center. Okay. Then you're going to have 2 points on the outside that are farther away than the two other points. So if you look at it, you can see that these two are the farthest away. Those two are called the vertices. So this is a vertex, and this is also a vertex. So those are called the vertices. The other 2 points on the shorter axes, they are called co-vertices, or this is a co-vertex and a co-vertex. The other 2 points that are in this diagram, these 2 points right here, these are your foci. Okay, this is a focus, and this is a focus. And we'll be graphing all of these things when we graph an ellipse. Okay, so let's get our equations first. So just so that we make sure we know where these variables come from, we're going to draw into our diagram also. So what I want everyone to do first is to draw an x-axis, or to draw, actually don't do that. Draw a vertical line right here. That's a horizontal line, my bad. And draw a vertical line right here. I want you to draw these. Oh, and I forgot to talk about the major and minor axis. Let's highlight for that. This right here, major axis. It's the longer one. This one right here, minor axis. Okay, so this right here, this first one is a horizontal ellipse, okay? I'm going to give you the equation first of a horizontal ellipse, then I'll explain what the variables represent, okay? So it is x minus h squared over a squared plus y minus k squared over b squared equals 1. X minus h squared plus y, this numerator here might look familiar because that's the equation of a circle right there. Okay, but the divided by a squared divided by b squared makes it an ellipse instead. Okay, so what are these variables? So I'm not going to label this is the vertex, these are the vertices, these are foci, I'm not going to do that right now. What I am going to do is say what A, B, C, H, and K are. So first off, this point right here, that's HK. That's your center. Okay, so now A is the distance from the vertex to the center. So from the center to any vertex. So I can say from here to here, this distance is A. This distance is also A. Okay. The distance from the vertex to a co-vertex, the distance from the center to a co-vertex is B. So this distance right here is B. But you could also call this B also because that's also B. That distance. And we also have C. Now you might be saying there is no C in here. Well, we need to find foci in your C units from your center, where C squared is equal to A squared minus B squared. So there's C units from your center. So let's say you have a focus here and you have a focus here. This distance is C. Okay, so it's this distance right here. Now it's always on your major axis on this particular ellipse. This is my longer axis because it's horizontal. So that is, that's the orientation too. Okay, or that's where the foci are, I should say. Okay, so that is my equation for a horizontal ellipse. So if you look, HK, you're going to take your center, and that's where how you get your center is looking at your equation. Then you're going to figure out what A is, and then you're going to know your vertices are A units from your center, figure out B is, so on and so forth. All right, let's do the equation of a vertical ellipse. So it looks almost identical. X minus h squared over, but this is b squared, plus y minus k squared over a squared equals 1. Don't forget the equals 1, otherwise it's not an ellipse. Okay, go ahead and draw on the major axis, which is your longer axis. So now you can see this is a vertical ellipse, if you couldn't tell before. And then your minor axis, horizontal. Okay, so this is still HK. Your center is HK. A is the distance from the center to a vertex. So it's this right here is A, right? Or the other long piece right there. The distance from your center to a co-vertex, that's B. Your foci are always on your major axis, so your foci would be located on this axis now. And this distance right here is C. Okay, now let's notice the difference. How are we going to be able to tell the difference between the equations if it's just going to end up being numbers in there? If you look, A is the bigger number always. If you look right here, A is the longer number, A is longer. So A is always bigger. So if this number is bigger, then it's horizontal. If this number is bigger, then it's vertical. Okay? I remember as H comma V, horizontal, vertical. So if this one's bigger, horizontal. If this one's bigger, vertical. Okay. Well, let's move on to organizing this in a table. Okay, so we're just going to put everything in a table so you have it. We have two different types of ellipses. We have a horizontal ellipse, and we have a vertical ellipse. Let's write those formulas again. Horizontal is x minus h squared, quantity squared, over a squared, plus y minus k, quantity squared, over b squared equals 1. Vertical, or actually let's just continue with horizontal. So horizontal, here's a sketch of one. Okay, and we can see above for the sketch how everything looks. What I do want you to notice is this right here. It says A is always greater than B. Look at that. A is always greater than B, and B always has to be bigger than 0. Therefore, they both have to be bigger than 0. Okay, length of the major axis. So actually, get rid of the C above because we're just going to use this. Okay, so here's your major axis. Here's your minor axis. Here's your vertex, your center. This is A right here, right? This is also A right here. So the length of your major axis is just 2 times A, 2A. Minor axis, this is B, and this is B, so it's 2B. The area, we're going to use the area of a circle for help. recall the formula, the area of a circle is area equals pi r squared. The reason why is because you do, this is a radius and this is a radius. So you do area equals pi times radius times radius. So in our ellipse, this is an A and a B. So it's pi times A times B. So our area is pi times A times B. The area formula doesn't change, so I'm going to just fill that in right there. Area equals pi times A times B. All right, vertical ellipse, x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay, remember, a is always the bigger number. You might want to write that down. A is always bigger. Okay, so that would look like so. This is your major axis. This is your minor axis. This is still A and A. So this is 2A, and then B and B, so 2B. Okay. As a reminder, I've said it a bunch of times already, but A is the distance from the center to a vertex. B is the distance from the center to a co-vertex. C is the distance from the center to a focus. And HK is the center of the ellipse. All right, so let's get graphing. The first thing that I'm going to ask you for when we're doing these together is our orientation, meaning is it a vertical or horizontal? You can tell by looking at the equation. If you look at the denominators, you can see this denominator is bigger, the second one, or in alphabetical order, H comma V, vertical. So this is a vertical ellipse. Next, I'm going to get my center. My center is HK. H is subtracted off of X, K is subtracted off of Y, and since there's nothing, that means that it's 0, 0. All right, so I'm going to graph 0, 0, my center. Okay, and now I need to get my vertices. My vertices are A units from my center, where A squared, remember, is always your bigger number. So A squared is 36, so A is equal to plus or minus 6. So since this is a vertical ellipse, I'm going to go up and down 6 units to get my vertices. Up 6, down 6. So I have 2 vertices. I'm going to write them out. I have 0, 6, and 0, negative 6. Yes, you can write it as 0 plus or minus 6 because that's the same thing. All right, next we're going to find our co-vertices. Our co-vertices are B units from our center, where B squared is 9. So B is plus or minus 3. I'm going to go right 3, and I'm going to go left 3, and then I'm going to say my co-vertices are at 3, 0, and negative 3, 0. I can connect these points to make my ellipse right now. I wonder how, if my iPad will help me make an ellipse. Will it? Oh, it's beautiful. Okay. I graphed these on the board last year, so I haven't done it on an iPad. Okay, so there's my ellipse. Gosh, that's pretty. Name a major axis, not name a major axis. Name the length of the major axis. Okay, so I want the length of the major axis. It's how long is this? I don't even look at that. I just say, okay, A is 6. 2 times 6 is 12. How is this about the smaller one? B is 3, so 2 times 3 is 6. Easy, right? All right, my foci now. So my foci, you have to use that equation that we said in the beginning of the notes there to get it. You get your foci by using c squared equals a squared minus b squared. C squared equals, where did I go? C squared equals a squared minus b squared. So I have c squared is equal to a squared is 36, b squared is 9, so 36 minus 9. C squared is equal to 27. And then I'm going to square root to solve, plus or minus, square root to solve, plus or minus. So I have c is equal to plus or minus, and then make sure you simplify that in simplest radical form. 9 goes in there 3 times, so 3 root 3. All right. So now I know that my my foci are 3 root 3 units away from my center. So I have to go, since this is vertical, up 3 root 3 units and down 3 root 3 units to get my foci. Now, what the heck is 3 root 3? So what I'm going to do, since I don't know what that is no, I'm not going to use a calculator. I'm going to use the root 27 to help me approximate it. So I say, okay, root 27 falls in between which two perfect squares that I do know? 25 and 36. This is 5, this is 6, so this has to be 5 point something. Okay, so this is 5 point something. Approximation, 5 point something. All right, so since this is vertical, I'm going up 5 and a little bit more, down 5 and a little bit more, and those are my vertices. So now they're, sorry, my foci, and they're drawn. If they start to blend, you can always label it. You can say, like, this is a focus, and the other one's a focus, but I think with being able to zoom on the iPad, that's no longer an issue. Okay, I do need to say their location, though. Still not using a calculator. I went over 0, and then I went up 3 root 3 and down 3 root 3. So this one is up 3 root 3, and this one's down 3 root 3. Oops. So 3 root 3 and 0, negative 3 root 3. Another way of looking at it without even looking at your graph is looking at your center. You went up and down from here. So it's 0, comma, positive 3 root 3, negative 3 root 3. Okay, last but not least is my area. I get my area by doing a times b times pi. 12 times 6 times pi is 72 pi. All right, let's try some more. Notice the rest of it is just graphing. There's 3 more. All right, this one here, I need the orientation first. So I look at the denominators. I see that this denominator is bigger, so this is a horizontal ellipse. I'm going to get the center next, which is 2, negative 3, HK. 2, negative 3, graph it. All right, now I need my vertices. My vertices are a units from my center, where a squared is 25, so a is plus or minus 5. So now I look to see which way I'm going horizontal. So I'm going to go right 5 and left 5. I'll go right 5 units and left 5 units. 2, 3, 4, 5. Those are my vertices. I can write down the location now. That is 7, negative 3, and negative 3, negative 3. You could always check and say, okay, this is plus 5, this is minus 5. All right, good, yeah, I did it right. It's a quick check there. All right, now I'm ready to get my co-vertices. My co-vertices are b units from my center, where b squared is 16. So b is 4 and negative 4. All right, so I'm going to go up 4 and down 4. Up 4, 1, 2, 3, 4. Down 4, 1, 2, 3, 4. And there are my co-vertices. My co-vertices are at 2, 1. And 2, negative 7. You can now go ahead and connect your 4 points to make your ellipse. See, that wanted to make it a circle, so I'm going to have to sketch that one myself, but I'll do a good job. Good enough, okay? All right, my major axis length is the longer axis. It's 2 times a, which is 10. 2 times b for the minor is 8. Foci, I get by using c squared equals, let me get a different color here, c squared equals a squared minus b squared. C squared equals 25 minus 16. C squared is 9, square root plus or minus, square root plus or minus. And I get c is positive or negative 3. So I don't have to approximate that. I know how to move 3 to the right and 3 to the left. Why am I moving right and left? Because this is horizontal. 3 to the right, 3 to the left. That is 5, negative 3, and negative 1, negative 3. A times b times pi. 10 times 8 times pi is 80 pi. Okay, next one. Oops, not 80 pi. A times b times pi. I did the last one wrong, too. I did the major axis times the minor axis. I just realized that. A times b times pi. 6 times 3 times pi. 18 pi. saying it out loud and I'm not doing it. A times B times pi, 5 times 4, 5 times 4 times pi, 20 pi. I'm saying it out loud, but I'm not doing it, so I fixed it at least. All right, next one. I need to know if it is vertical or horizontal. So I look at the denominators. This one's bigger, so it is vertical. Center, -2, -1. All right, so now I need my vertices. My vertices are A units from my center, where A squared is 81. So A is plus or minus 9. Since it's vertical, I'm going to go up 9 and then down 9. Write down my 2 points, -2, 8, and -2, -10. All right, now I need my co-vertices. My co-vertices are B units from my center. B squared is 64, so B is positive and -8. I'm going to go right 8, and then I'll go left 8. So I have the points 6, -1, and -10, -1. Major axis and minor axis length. I won't make a mistake this time when I get my area. So my major axis is double 9, which is 18. Minor is double 8, which is 16. I'm going to go ahead and connect my points to form my ellipse. Now, when you're graphing this one, you might be saying to yourself, like, it's really close to a circle, right? Oh, that was ugly. It's really close to a circle. And it is, you're right. It is really close to a circle. That's because, oh my goodness, I can't even look at my ability to draw an ellipse. It's so bad. Let me try it one more time. Try going like this. Oh gosh, no. Yeah, that's right. I'm going to do it in the video. Let's do it in 2 pieces. Oh God. Oh gosh. Try it like this. Come on, help me. It looks pointy on the ends. It's not pointy, round. Okay, that's as good as I'm going to do. But it almost looks like a circle, but that's because A and B are 9 and 8. If they were 9 and 9, it'd be a circle. If it was 8 and 8, it'd be a circle. 9 and 8 are really close to each other. All right, so I'm going to do my area while I'm here. It's A times B times pi, 9 times 8 times pi, which is 72 pi. All right, foci are next. Foci I get by doing c squared equals a squared minus b squared. So I have c squared is equal to 81 minus 64. C squared is equal to 17, square root plus or minus, square root plus or minus, and I can't simplify root 17. So I need to go root 17 to the up and down. I almost said to the right and left. Up and down because it's vertical. So I need to approximate root 17. It's a little bit more than root 16, so this is 4 point something. So from my from my center, I'm going to go up 1, 2, 3, 4, and a little bit more. I'm going to go down 1, 2, 3, 4, and a little bit more. And there are my foci. If you look at your foci, they're floating, right? They're in between these 2 values right here. So I can't just look at it and say where it is. I'm going to use my center for help. Here's my center. I went vertically, so I went up and down, which is my y value. So I changed my y value. My x value didn't change. It's -2. How did I change my y value? From my y value of -1, I went up and down root 17. Okay. Last one. So I can tell this is an ellipse because there's an x squared and a y squared and there's a plus separating them, but it's not in the form that I'm used to. The form that I'm used to, it does not have coefficients in front of x squared, and it's equal to 1. So to get it equal to 1, I'm going to divide everything by 144. Both of these fractions are simplifiable. 4 goes into itself once. 4 goes into 144 36 times. 36 goes into itself once. It goes into 144 4 times. And then that simplifies to 1. So I have x squared over 36 plus y squared over 4 is equal to 1. And I can graph that. So first off, the orientation. If you look at the denominators, this one's bigger. So this is a horizontal ellipse. is center HK 0, 0. All right, now I need to find my vertices. They're A units from my center, where A squared is 36. So A is plus or minus 6. So since this is horizontal, I'm going to go right 6 and left 6. So I have 6, 0 and negative 6, 0, or you can write plus or minus 6, comma 0. My co-vertices are B units from my center, where B squared is 4, so B is plus or minus 2. So I'm going to go up 2 and down 2. So I have vertices at 0, 2, and 0, negative 2, or 0, comma, plus or minus 2. All right, I'm going to go ahead and graph my ellipse now. That's better. Okay, the major axis is 2 times A, which is 12, and minor is 2 times B, which is 4. My area is A times B, which is 6 times 2 times pi, 12 pi. All right, now I'm going to get my foci. C squared equals A squared minus B squared. C squared equals 36 minus 4. C squared equals 32. Square root plus or minus. Square root plus or minus. This is simplifiable. 16 goes in there twice, so 4 root 2. All right, I need a graph to the right and left for root 2, but I don't know the approximation of 4 root 2, so I'll approximate root 32. Root 32 is less than root 36 and more than root 25. So this is 5, this is 6, this is 5 point something. So this is 5 point something. All right, so horizontal, right and left, 5 and a little bit more, almost hitting those vertices. All right, once again, this point is floating in between 2 points. I can't just guess where it is, so I'm going to use my vertex for help. So from my my center for help. From my center, I moved horizontally, so this is what changed. From 0, I moved left and right for root 2. So 0 plus or minus for root 2. You do not need the 0 because you can just say it moved up right for root 2 and left for root 2. And then comma, it did not move up or down at all. All right, that's it for graphing ellipses. Now you can move on to writing equations of